Dear students, today we discuss about the magnet and its effect. So, what is magnet? It is a material or object which produces a magnetic field. How it produces magnetic field? It is made up of a group of ferromagnetic metals such as nickel and iron. This magnetic field is produced from the dipoles, the magnetic dipoles, that is the molecular field, the molecules present in the magnetic material. The magnetic field is due to the molecules, the magnets. The molecules are arranged so that their electron spins are in the same direction. Each molecule has the electrons. Each electron has two different spins, half spin plus half spin and minus half spin, that is up spin and down spin. So here the all electronic spins of the atoms of the molecules are arranged in the same direction. In an unmagnetized steel bar, they have the random variation. See here, the dipoles are in random oriented, but in the case of steel bar, the molecular magnets, see here, the molecular magnets are lines up, so it is arranged in orderly manner. So the electronic spin of the atoms and the molecules of the ferromagnetic materials are arranged in the ordered manner, so it produces a magnetic field. Then what is a magnetic field? It is an area around a magnet in which there is a magnetic force. So the magnetic field is nothing but a force around the magnet. So it is the north pole, it is south pole. So the molecular magnets, the dipoles are arranged in ordered manner inside this. So it produces the molecular field, that is We's molecular field. This is called the magnetic field. How the magnetic field is produced artificially? The magnetic effect of electric current. The current is nothing but the movement of electrons. The electrons are responsible to produce the current and the magnetic field. When the moving electric charge can create magnetic field, suppose a current is passed through a conductor like nickel, the copper or aluminum, it produces the magnetic field. This is explained by Fleming right-hand rule. When a current is passed through this direction in a conductor, the magnetic field is produced like this and in this direction. See here, so it is a plane. The current is passed through the conductor. The magnetic field is produced here. What is magnetic flux? It is a measurement of total magnetic field passes through any given area. It is the measurement of total magnetic field passes through the given area. See here, in the given area is this one indicated by A. This is the magnetic field passing with the two poles of the magnet. The magnetic lines of force is passing here. When we place extend the surface area of A, the simple flat surface A as our test area, this is the test area. This angle, inclined angle is theta between this surface and the surface of the object. So it produces a magnetic flux. Suppose the The flux is here phi is equal to BA cos theta. Suppose the surface area and the magnetic surface area are parallel. So the angle between these two surfaces becomes 0. So the magnetic flux is equal to BA. And then if the test area, the surface area is kept vertical, that is parallel to this magnetic lines of force and perpendicular to this magnetic surface area. So the angle between these is 90 degree. So we will have the magnetic flux, that is a zero magnetic flux in the surface area. Then what is electric dipole moment? The electric dipole moment is nothing but a property of dipole. Already we have mentioned the magnet is made up of dipoles. The positive and another is negative. Suppose we consider a charge, there are two types of charge, minus Q and a plus Q charge in the electricity. They are separated by a distance 2r. So the electric dipole moment is indicated by P and this Q, it is a charge. The Q minus Q or plus Q, any one charge is taken like Q, and the distance between the two charges is taken as 2r. Here a Q is a scalar quantity, but the r is the distance. It is a vector quantity. Suppose the minus q exert a force on here, or this plus q may be exert a force on this one, or this minus q make a displacement to this distance, or this charge make a displacement from here to here. Now we are considering this displacement minus q to plus q. So the displacement is a vector quantity. So we are indicating the electric dipole moment as p vector. So q is a scalar quantity. So r is the distance is a vector quantity. We are putting the arrow here. In the same way, what is magnetic dipole moment? It is the property of the magnet that interacts with an external applied field, which gives a mechanical moment. In the electricity, there are two charges, minus q and plus q, separated by a distance 2r. In the same way, there are two dipole moment, pole strengths. Here, there is a south pole, it is a north pole. In this south pole, the pole strength is M. Here also M. Likewise, in the electricity, minus Q and plus Q. Here, the pole strength is M and M. So, M is the scalar quantity. The displacement, the force exert on the north pole and the force exert on the south pole by north pole. So the displacement from south to north or north to south is a vector quantity. So the magnetic dipole moment, capital M, is taken as M into 2L vector. So magnetic dipole moment M, capital M vector is equal to small m. Small m is a pole strength, like charges in the electricity, and the distance separated by these two charges, these two pole strength, is 2L. So it is a 2L vector. So magnetic dipole moment M vector is equal to small m into 2L vector. What is pole strength? A pole strength is a measure of force exerted in one face of the magnet to another face of the magnet, presented by equal and opposite poles. So the pole strength is given by Prm is equal to capital M divided by 2L. So the force exerted in one phase of a magnet to another phase of the magnet presented by equal and opposite poles. This is a minus, south is the minus, north is a positive pole. So the pole strength small m is given by, it is equal to capital M. Capital M is the magnetic dipole moment and it is divided by 2L, the distance separated by this.